Alright, hey everyone. Um, Sorry I couldn't be there today, but hopefully this will do a good enough job of teaching you the lesson here. So, we're in 3.3, and we're going to study different forms of the equation of a line. So, just a short summary of the section. What we've been doing so far is just studying how to graph lines, and if we're given the equation, to work with it, maybe plug in a couple points, and then graph the line. But now we want to actually study the equations themselves and what they mean and the different forms. So here I'm saying that math is confusing, and it can seem like you're doing a bunch of random things that have no connection. So random things that have no connection or purpose. And I'm sure that's how it feels. That's how it felt when I was studying early on, and for a long time. What's the point? How does this relate to that? It seems like just a bunch of rules that you're following, and it can seem like, how in the world are all these things related? So, and maybe even math people feel that way. So one way that you try to make sense of things as math people is by emphasizing something called form. You'll hear that a lot. In fact, that's what the part of the title. It's the three forms of equations of a line. So you might have seen something like this before. If you consider this equation here, y equals negative 5x squared plus 3x minus 2. If you could take a guess as to what type of equation this is, it has a special name. It's called a quadratic equation. And we may get to this at some point in the course, but I just want to make a point with it. Just the way that this is written, see, a general quadratic equation says y is equal to ax squared plus bx plus c. That's what's called the general form, or the standard form. And once you fill in these numbers and you have it written just this way, you know everything there is to know about the curve, or I'm sorry, you know some specific things there is about the curve. You know how to fill in the quadratic formula, which is x is equal to the opposite of b plus or minus the square root of b squared, and blah 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 blah. I don't want to emphasize the point too much, or get off the point too much, but so by knowing a, b, and c, we can figure out the quadratic formula, which means we'll know where this curve crosses the x-axis, if it crosses at all. So that's something that we can know about it. And if you remember the type of curve this is called, it's called a parabola. Actually, this parabola is opening down. I drew it upside down, so that might be more the shape of it. So depending on the scenario, we might want to know something different about whatever it is we're talking about. So this equation could represent the path of a ball. Let's say you throw a ball, it might go up and then come back down like that. If you want to know where the ball peaks, you won't find that from this equation. That will come from another form. It would come from what's called the vertex form, plus k. So here, if I were to write this, and you can change this equation into this form, and that would tell you right where does the ball reach its highest point. This equation tells you, or you could find pretty easily, where the ball crosses the x-axis, or where this curve crosses the x-axis. So depending on what you know, different forms will tell you different things. I hope that's clear. So we can know a lot of things about this curve. And some of those things are just what I said. So if we just change where everything is, that changes what we know right away. That's what I was saying about if we rewrite this curve this way, then we'll know where the ball peaks at, or where the highest point in the curve is, or the lowest point, depending on if your parabola opens up or down. So it changes what we know right away about the equation, or the curve. So, okay, we're not talking about quadratics, but I was just trying to make a point that how you write something is extremely important, where you write it. If I write the x in a different spot, or I write these numbers in different places, that just changes what it's telling the math student or whatever, even though it doesn't really change the curve. The graph is still going to be the same, but what the equation's telling you is going to be different. Remember how I keep talking about understanding something algebraically, meaning understanding the equations versus understanding the picture. So when we write equations differently, the picture never changes, but what we know about the picture is changing. So in our study of linear equations, we will learn three forms, that's the title of the section, of the equation of a line. Okay? So, the first form, one thing we've already learned about is slope, right? So, the first form, we can kind of get it by moving things around in the slope formula. So, what's the formula for slope? It's m is equal to y2 minus y1 over x2 minus x1. Hope you got that since you just had a test on it. This is the rise over the run. Remember, rise, because y is going up and down, that's the rise, and x is side to side, so that's the run. Okay, so let's mess with this formula here. x2 minus x1 over y2 minus y1. Let's see if I can get a different colored pen here. So, if you can actually multiply both sides by this whole bottom part here. So if I multiply both sides by y2 minus y1, then since the bottom here is y2 minus y1, it'll cancel. So let me make sure that whatever I do to one side, whoops, oh, I'm dyslexic today. This is, okay, Mr. Rodriguez is being confusing. It's m is equal to y2 minus y1 over x2 minus x1 on the bottom. Sorry. So now I'm going to multiply both sides by x2 minus x1, and then x2 minus x1 on this side. So pay no attention to that. This is going to cancel here, because you see you have x2 minus x1 on the bottom, and then you have x2 minus x1 multiplying the top. So the whole thing cancels. So now if I rewrite everything, I'll have y2 minus y1, see right here, equals m times what? This, x2 minus x1. And this is our first form of the equation of a line. It's called the point-slope form. Okay? And the nice thing about this form is that depending on the information you're given, different forms are useful. So this is good if you're given the slope and a point. Well, duh, right? It's called the point-slope form, but that's why it's useful, because if you just know the slope, see right here, m, and you know a point, then you'll know right away what the equation of your line is. So really, they don't write y2 minus y1. Instead, they just say y minus y1. So instead of writing y2, they just write y is equal to m times x minus x1. And this is something that nobody ever tells you in math, but you just kind of have to learn to get used to. When you just write a y, that means a general variable, like you don't really know what y is supposed to be. When you write y1, you're talking about a specific thing. So they have to give you a point, like let's say 3, 4. Well, that means 3 is my x1 and 4 is my y1. And I'm not supposed to fill in this y and this x because those are supposed to be, they're supposed to stay y and x. And then of course they have to give me m. So you might call y1, x1, and m constants that get filled in, and then you can figure out what your equation is. But y and x, those don't get filled in. Hope that's clear as mud. So, okay. Example 1. This might clear it up a little bit. So example 1, it says find an equation for the line through -2, 5 with slope, so m equals -3, and solve it for y. Okay, solve it for y means we get y by itself. So first thing we want to do is write the point slope form. Remember, this is useful when you're given a point and the slope. I know that sounds obvious probably, but all you have to do is plug things in and move things around. So that's why it's nice. So they give us x1 and y1, you see? So that's y minus, what's my y1? It's 5, equals m, -3, times x minus, and then this is my x1, -2. Alright, now we have to remember our rules of distributing. So we have a negative and negative, so that's going to make a positive. So we have equals -3 times x plus 2, y minus 5. Now it says solve it for y. So let's first distribute this -3, and then we get y is equal to -3x minus 6, because -3 times 2 is -6. -3 times x is -x, and we still have y minus 5 here. Then we'll go ahead and add 5 to both sides, and this makes it y is equal to -3x minus 1. So we've solved for y, y is by itself, and this is going to be our answer. So with a little bit, took a little bit of moving things around, but that's pretty much all you have to do. Alright, now sometimes you have to do an extra step because sometimes they'll just give you 2 points. So remember, with 2 points we can find the line graphically. If I have 2 points, okay, let's say I have this point here and this point here, then there's my line. Well, if I can find it graphically, I can find it algebraically. But there's got to be a way to do it. You just have to think of the trick. So if I have 2 points, let's say example 2, part A, they give me 3, 5 and 4, 7. Okay. Well, this is called point slope form. So they didn't give me the slope, but there's a way to find it, right? What's the equation for slope? M is equal to y2 minus y1 over x2 minus x1. So we just plug in. This is going to be my y2, this will be my x2, this will be my y1, this will be my x1. So 7 minus 5 over 4 minus 3. Right? 7 minus 5 is 2, last time I checked, and then 1, so the answer is 2. So the slope is 2. Alright? But this is called point slope form. Well, now I have the slope, but what point do I use? Did they give me a point? They gave me 2 points. They gave me more than enough, so I can just pick either one. I'll just pick this one. So pick either one. Okay? So now we write our formula. Y minus y1 is equal to m times x minus x1. And just fill it in. We know m, and we know these because we picked this point. So y minus 5, that's my y1, is equal to 2 times x minus 3. Okay? Again, distribute the 2 first. So we have y minus 5 is equal to 2x minus 6. And then add 5 to both sides. So we get y is equal to 2x minus 1. and put a little box around it so I know that's your answer. Nick. Okay, so that's the point slope form. That's our first form. Um, that's um, that's again, that's a nice form depending on what you're given. The most popular form that you guys probably already know is called the slope intercept form. And we don't have to put too much emphasis on names, but we have to call it something. So this goes y is equal to mx plus b. So this is my slope, and maybe you guys remember what this thing is. This is my y-intercept. So that means this tells me what? This tells me how slanted the line is. So if I have a slope of 100, that means I have a really steep line. Let's say I have a slope of 2. So the line might look like this. But if I know this equation, I immediately know what this is. This is 0, because the x value has to be 0 if I'm on the y-axis, right? Comma, b. Whatever b is, that's what goes there. So the nice thing about this form is you immediately know how slanted the line is. You know the slope. And you know where it crosses the y-axis. Okay? So let's have a look at example 4. They give you a picture where you have this line here that crosses the y-axis at 0, 3, right? And then you know this point here is 3, 1. So this is 3, 1. Okay, so figure out the equation of the line and from the picture. So right away, what do we know? Let's write our form, mx plus b. We know b right away. Remember, there's only certain things in the equation you're supposed to fill in. I'm not supposed to fill in x. I'm not supposed to fill in y. I'm only supposed to fill in b and m. So I know b right away because that's where it crosses. And so 3 goes right here. So b is 3. You could write on the side, b is equal to 3. How do I figure out m? Well, you guys are pretty good at this. You're looking at the picture and figuring out the slope. So since this is 3 and this is 1, if it's better to look in the book, by the way, if you guys open your books to this page, but we'll try to do it here. If I go down 2 and then over 3, that means I had to rise -2 and I had to run 3. So again, it's better to look in the book. You go down -2 and you go over 3, down -2 and over 3. So I know my slope. Okay, so we know this. So now just fill it in. -2 over 3x, and then what's my y-intercept? 0, 3, so b is 3. And there we go. Okay, so that's a popular form because it kind of tells you a lot about the nature of the you know, how slanted the line is and everything. So it's a very easy form to work with. I think that's why students like it a lot. Okay, third form. The third form is called standard form, and this is probably students' least favorite form. It's like, why do we need another form anyways? This form is ax plus by equals c. And I think the reason it's students' least favorite is because it probably has the most letters. Another reason might be because x and y are on the same side, but just you got to learn not to make a big deal out of those things. Just the fact that x and y are on the same side, don't let that overwhelm you. Get used to just moving things over to the other side. If I move this over to this side, that makes it negative. Just let that just click and become normal. So the advantage of standard form is it's used a lot in applications. So, eventually solving linear or systems of linear equations is a huge part of using math in the real world. And when you do that, you want to write your linear equations in this form. Um, and in real world problems, just the way they're presented sometimes, it's easier to think, oh, this is what goes in front of x, this is what goes in front of y, and this is what goes in front of c. So on page 174, there's a little paragraph that says, if X students paid $5 each and Y adults paid $7 each to attend a play, and the total sales was $1,900, then you immediately know the equation in standard form. Because students, X students, paid $5 each. Y adults paid $7 each. And then the total amount of money that was made was $1,900. So you have an equation relating to telling you how many students went versus how many adults went, or it relates the two. That's what I'm saying. And then if you had another paragraph maybe telling you the total number of people that attended, like let's say there was 500 people, then you could figure out the amount that, or the amount of students and versus adults that there were. So, okay, so that's why standard form is useful. Another important fact about standard form is any line can be written in standard form. What do I mean by that? Well, let's take y equals mx plus b, our favorite form. This is good because immediately I know the slope of whatever line I'm talking about. But the problem is that what if I have a vertical line? Well, if I have a vertical line, then the slope is, if you guys remember, it's undefined. Well, you can't, undefined isn't a number. Maybe you could say it's infinity, but infinity is not a number. It's a concept. It's getting bigger and bigger. So you can't write, you don't have anything for m to plug into this equation. But you always have a way of writing it in standard form. And for any vertical line in standard form, it would be ax plus 0y equals c. So you're just saying that y has to be 0 in standard form. So that's one advantage, and that's important. In math, when you're talking about equations and things, you always want to have a way of writing everything. So to the math teacher, that might be a bigger deal than the student. So okay. Now let's another thing is that we're gonna have to do, you're gonna have to do in the homework and on the test, is being able to go back and forth between two different forms. So if I give you something in slope-intercept, so let's say y is equal to 2 over 3x plus 1. How do you write it standard form? And the way you would do it is you move things around, so you'd have to multiply everything through by 3 and then subtract 1, and you get, subtract 2x, so you'd get 3y minus 2x equals 1. So how do you do this? Okay, you have to get used to that, and that's what example 5 is about. So we have y equals 1/2 x minus 3/4. It says write this in standard form. So the easiest way to do it is to multiply everything through by the biggest denominator, or actually by the common denominator. And here the common denominator happens to be 4. So let's just multiply both sides of the equation by 4. Okay, and we remember doing this. So 4, and then we distribute the 4, so we have 4y equals, and then 4 times 1/2. Well, what's half of 4? That's 2. So 2x, and then there's a 4 on the top here and the 4 on the bottom here, so when I distribute, I just get back a 3, and everything looks a lot nicer. Now, standard form has ax plus by equals c, so my x and y have to be on the same side. Okay? So if I subtract 2x from both sides, that's the last step. So we have negative 2x plus 4y equals negative 3. And that's my answer. So, alright, so I'll go ahead and leave it there, and we'll pick it up after you guys get back. Have a good break.